Yeah, good evening, everyone. My name is Fabian. Title of my talk is "What's Wrong with You, Recruiter John? A Non-Trivial Recommender Challenge." And this challenge is actually the following. So I'm talking about job recommendations. And here the problem can be formulated in the following way. So given a user on a social business network like Xing, the goal is to recommend those job postings that are, one, interesting for the user, and two, for which the user himself is actually also an appropriate candidate. And Xing, who of you knows Xing? Amazing. That's really amazing. So I actually don't have to explain that Xing is like LinkedIn, but let's say in a different version. So that's very cool. So actually, when you log into Xing, you are here on this is basically the start page that you would see when you log in. So you have here the different sections of the platform, and then you have some sort of timeline below to see what your contacts are currently doing, and then at the very top you have job recommendations. Also, if you switch then from the start page to the so-called jobs marketplace, there you can search for job postings in your city and so on. And again, you have here also job recommendations presented in a slightly different form, because here we list also reasons why certain things get recommended. And so like looking a little bit at these items that we are recommending. So if you look at the key properties that a job posting has, of course it has a title saying something like data warehouse manager in Hamburg. This posting is created by some company, so the company where you would work for. You have some employment type, some metadata such career level information. Is the company rather searching for a junior or a senior person? Then you of course have the full text description of this item. If you scroll down, then you see, for example, contact person at this company. I mean, every company of course has a list of employees that all have a Xing account. And you also have some, the location, of course, that is attached to a job posting, and also some sort of social benefits that the company is offering. So whether you are allowed to bring your dog to work, or whether you can do a home office and these things. These are the items that we are trying to recommend. And then on the other hand, we have the user in the platform. So it's like every user has a profile where he fills in his CV and the skills that he has, so what kind of programming languages he is skilled in. Then for a given user, you also have some of the social network. So, on the one hand, explicit information like these are my contacts, but also part of the social network is like also the companies I worked for, the events I went through. So there's quite some information where you can implicitly understand the social network of a user. For a user, you also have interactions, so clicks that a user is performing, bookmarks that a user is doing. People can also delete, for example, recommendations, part of this data is actually also the impressions, items that were shown to the user, but user didn't click. And then, of course, I mean, when you look at one user, it's one thing what the user is doing, him or herself, but then, of course, you have all the interactions, so the same stuff then also about all the other users, so interactions from similar users. Just one quick explanation how our current system, the current recommender system Xing works. So it's an ensemble of different recommender strategies where you have some content-based features, so where we basically takes a profile of a user, translate this in a search query, and then search in the document collection, so search in all the job postings. We have social features like how many contacts does a user have in a given city. So the more people I know in a city, the more likely it is that I'm moving to this city, or I'm willing to move to this city when I'm changing a job. Usage behavior features, so on what kind of postings did a user click on. What we are doing here is that we, for example, create an interest profile from the clicks that a user is performing. So, for example, then you see that a person is clicking very often on data scientist jobs, and so from these clicks, then actually what we do there is also we take this interest profile simply to search then for jobs that are matching this interest profile. And we are also doing collaborative filtering. So people that recommending items that were clicked by people who are similar to me, and then similarity is actually measured by different means. So we actually have 6 or 7 collaborative filtering components running in parallel. And what we do is then pretty simple. So we learn, we use logistic regression, which means that we learn like every recommender component gives out an item plus a relevance score. And we try to have this relevance score model this as some sort of probability that the item is really relevant, so interesting for the user. And then we learn how we learn basically this function that tells us how do we need to combine these scores that were generated by the different sub-recommendation engines. And then given this, actually, we apply also some additional filters. For example, we dampen a little bit the score of postings that are far away from the user. Or we also have some filters that actually try to diversify the top K list of the recommendations. And part of this is, for example, a filter that, we're actually earning money with job postings. So what we in the past always counted is that one click on a job posting is worth 50 cents, and nowadays actually we are crawling job postings from the entire from the web. So we have something like 750,000 job postings typically active on the platform. These job postings are primarily in Germany or in the German-speaking market, so Germany, Austria, and Switzerland. And most of these postings are crawled, but some of these postings are also created by companies, and they actually pay on the platform. So they actually pay like 300 euros per month so that the posting is on our platform. And this monetary-based diversification is then also trying to ensure that the probability that a paid posting for which a company paid money, that this appears a little bit more at the top of the ranking. So some challenges that we actually are facing, and things that that make our daily work difficult are the following. So if you look, for example, at the recruiters who write the job posting descriptions, they are, of course, they have their own language to describe things, and sometimes they're also not the domain experts. So if a recruiter is searching a data scientist, and he's the one that is writing down the description, then it may not be actually that accurate. And here are some real examples. So, for example, we have a job posting for an international sales manager. Sounds quite fancy, but actually, if you look at the posting, then it turns out it's actually a call center agent that is paid on an hourly basis, so 10 euros per hour. Here again, we have a sales manager. So same word is basically used, but this time it's really a sales manager for B2B customers, and that's a kind of job where you get like 80k euros per year, depending on your sales performance. Then often also what we observe is that like if it comes to technical jobs, then you see something like we are searching for data scientists skilled in Hadoop, Elasticsearch, Scala, Python, should have 5 years of experience in data mining, should have a PhD in computer science or mathematics or some related field. So it's like there's so many things in there. And actually for this particular example, if you look at the posting, actually what they're searching is just a data analyst who's skilled in SAS or Excel. So it's kind of, what people write actually in these job postings is not necessarily the truth. And same actually counts for the people, of course. If you look at Paul, the candidate, let's say, what people write in their profile, I mean, this guy is currently a CEO, and if you look at his profile, you actually see that he's a network engineer, currently unemployed. Also very junior, so that guy is maybe 25 years old, and or this person, again, this data scientist example, is someone who has more than 100 skills in his profile, so it's an all-rounder, can do everything, can solve every single task. But then actually, if you look at this profile, you rather get the idea that he's maybe a BI engineer, can also do some SQL, and like it's this old school ETL guy, and who just pimped up his profile with some fancy buzzwords. Or also this one is a good one. So it's also a sales manager. But actually, if you look at the profile, then you see that he's a shopman in a kiosk. But I mean, it's up to him how he describes his job. So overall, you can say there's quite some blah blah. So some things written in the job postings and in the profiles that which make it difficult to really understand what is the company searching for, and what is a candidate actually offering and skilled in. One other challenge actually that we are facing is that, I mean, if you look at if you now look at content-based features that you want to exploit for job recommendations, then one obvious choice is to look at the profile of a user. So this is my profile, but there is one disadvantage. I mean, the profile typically describes also the past, what people worked in, but it doesn't describe actually what a person wants to do. So I was working as a postdoc in Delft, and by no means I wanted to continue as a postdoc at university. I'm not crazy. So that's, so this means simply using this profile also doesn't make sense from or you have to be careful at least, because it describes your current situation, not the situation you want to go to. And this you can also see if you look at what kind of postings do people bookmark. So just looking at the location, you see actually that 35% of the bookmarks are performed on items, on job postings that are in a radius of 50 kilometers away from the user. Then 22% of the bookmarks are performed on postings that are up to 200 kilometers away. And the majority of postings is actually performed on postings that are 200 kilometers and more away. Then similar, so this means like shows, so just recommending jobs from the same city you are located in is not enough. You need to understand like infer, okay, where is it likely to go? For example, I mean, in Germany it's kind of easy because everyone wants to go to Hanover, so that's something you can, of course, put in your, you can have some priors basically there. So the popularity of a place can be used, but then also, again, the interactions that the user is performing need to be analyzed to understand what the current demands of the user are. Also, if you look at typically career path patterns, so you can, in your profile, you can specify certain career levels. So at one point you are a junior, and then people climb up sometimes the ladder from junior to senior, then they become manager and then senior manager. And here you see also again bookmarks like what are juniors. No, these are not bookmarks, these are actually the career path transitions. So as a junior, what's then the most likely next step that the user is doing? So most people actually stay as a junior, but then also 47% move on. Then for senior, it looks the following way. So most transitions, like from one job to another job, are then actually at the same career level. And then, yeah, similar, this is also for managers then. But also, if you look at the manager and senior manager, okay, 50% for both, let's look at this one, senior manager. 52% of the people, once they are a senior manager, they stay at this career level. But then there's also quite high percentage, so 48% of the people, they actually make a step down the ladder. Yeah, these are actually things that some challenges or things you have to keep in mind when working on some job recommendation problem. And we actually started working on job recommendations 3-4 years ago, and this one of our key performance indicator for the recommender system is click-through rate. So the probability, so we show a list of recommendation to the user, and then the probability that the users will also click on the items. And here you can see over time how our click-through rate developed. So for example, here we start with 2014, and it's actually one pattern that you can often observe is that at the beginning of the year, click-through rate on job recommendations goes down. Maybe that's because quite some people change also job when the new year starts. I don't know exactly. And then actually over 2014, we didn't put much love into the recommender system, so the click-through rate actually went down. So in 2015, beginning of 2015, we intensified the work a little bit. We worked on, for example, latent topic modeling, so that allows us to find better similar job postings, so postings that are similar to the ones that the user liked previously. We worked also on entity resolution, which means that given a job posting, we try to extract the actual job roles that people may mean or refer to in this job posting. And those things actually help to raise the CTR. And then actually we were wondering, like, because the increase was quite high, so we were wondering, okay, maybe this is not really caused by our efforts. So the trust in ourselves was not that high. So we actually did a BA test, so whether these changes really made sense. And since then also the CTR in total dropped. So this had actually a positive impact. So then actually also what happened last year, end of last year, that we increased the inventory from 100,000 job postings to 750,000 job postings. That actually also had a positive impact. And then 2016, we kind of were running out of ideas. So what we thought may be a good idea is if we start organizing the Recommender Systems Challenge and ask all the smart recommender systems researchers to help us finding some new ideas. And this recommender systems challenge is not an online challenge, so we don't know yet how the ideas that are developed there will have an impact. But we are pretty confident that when we use this, I mean, the CDR will go up like crazy. Maybe some words on this recommender systems challenge. So if you go to rexyschallenge.com, you can start participating if you like. And some of you I know are also participating in the challenge, which is very cool. So this again is the original problem definition that we are trying to solve. So recommending items that are interesting for both, let's say that the user should be interested in the job and also user should be an appropriate candidate. For the recommender systems challenge, this is an offline evaluation. It's actually the following. It's given a user, the goal is to predict those job postings that the user will interact with. And for this, you have profile data of 1 million users. You have the interactions that those users perform, so clicks, bookmarks, and so on. And also impressions, subset of impressions. And then the corpus of job postings. And then the question is, like, on which job postings will a user click on, or which job postings will a user bookmark? That's a challenge task. So the data set itself, so you have some user demographics, for example, the job title of the user, discipline, industry of the user, the career level, and also some details about the location of the user. It's slightly more than 1 million users. For job posting, so the items that should be recommended, we also have roughly 1 million users. They have similar attributes. And then we have the interactions and impressions. And also when you start participating in the challenge, I mean, what you will be able to download is like the task files, so the users for which you are then supposed to submit a solution, and also the candidate items which are then still active for that week, for which you should predict on which postings will a user interact with. And what we don't give out is the solution, so those interactions that the user actually interacted with. Sorry, this 1 million is definitely wrong, I think. No, should, yeah. And one thing that we are doing, so all the data that you can download is anonymized. So we don't give out strings, but we give out IDs. So like a job title, like data scientist, is not, you don't get the string, but you get an ID, which also has some advantage for you, because first you don't need to understand German. So most of the profiles and postings are in German. So, I mean, you just work with IDs, and it also has the advantage that you don't need to deal with synonyms, because we have this, we have a huge taxonomy also, and like for a given job role, we have like all the a lot of alternative labels, and so that's something you would then benefit from. Also, there's a little bit noise in the data set, so there are some artificial users in there. As evaluation measure, we use actually a mixture of different, of precision at k, recall at k, and then something that we call success at 30. The probability that at least one relevant item was recommended to a user. And those scores are then for all the users simply summed up, and that's then what the top teams achieved regarding the evaluation measure. So actually, so that's a ranking from today. So the team Dave Ixter is top team. So I heard rumors that the person is actually the main person of this team is actually in the room, but I'm not sure whether he's willing to raise his hands and show who he is, but nice. Yeah, no, very cool. So it's actually also then funny to see if you look at so I mean, it's a neck-to-neck race. So, and I know there's also the team 3. The fourth is also here, Pumpkin Pie. And I'm pretty sure that the last weeks will be quite tough. And I'm curious who will then in the end win. If you look, for example, at the teams, it's actually also interesting to see. So these are the teams ordered by the number of submissions that they did, and then you see the number. So there's one team that has like more than 400 submissions. There's another team that has something like 250 submissions, and it's quite interesting actually to see that there's quite some engagement. So there are around 20 teams that have at least 50 submissions. So pretty cool. And it's also interesting to see that actually not only the top teams are submitting a lot of solutions, but also teams who are somehow at rank 30 or something. So this, on the x-axis here, you have the best rank that the team achieved at the time when they submitted. And on the y-axis, again, the number of submissions. And it's interesting to see, you have, for example, also at rank 30, you have teams that submitted something like 75 solutions. So, I mean, it's cool to see, and on the other hand, also a little bit sad if you are at rank 50 and you have 50 submissions, but then do not make real progress. But it's still cool to see that, throughout the ranks, there's actually a high engagement. So, challenge is actually ending this month, June 26th. So there are still 3 weeks to go. So if you are interested, then go to rexeschallenge.com and then follow the links. There will be prizes. The winner will get 3,000 euros. There will also be a workshop at the Recommender Systems Challenge, which also the top 3 teams are supposed to or have to participate in order to get the prize money. And for Recommender Systems Challenge 2017, if we are allowed to continue, then actually our dream would be to somehow move to include also some online evaluation part to not only benefit, let's say, from the smart ideas that all the Recommender Systems researchers are developing in a way that we then see the algorithms and can implement them ourselves, but ideally would be if those solutions that the teams submit, if we can immediately roll them out to the users, and that then also real users can benefit from these recommendations and maybe then find a job via the recommendations that the participants of the challenge are computing. That's it from my side. So thank you very much. Yeah.
What's the plan for next year's challenge?
Actually, I think we would like to continue to work on job recommendations, because we think I think it's a very tough problem then. And I mean, as I said, so ideally, it would be possible that this works in an online fashion. So, for example, in a way that you maybe still with pre-computing these recommendations, but that you would go to the Recommender Systems submission page, then download the data set, get the latest snapshot of the data set, submit your solution, and then, we would then include these recommendations into the real job recommendations that are rolled out to the people. So I mean, to give you an idea also regarding the scale, I didn't talk about that. So on a typical day, we are delivering, or we are handling something like 5 million recommendation requests. So it's sometimes up to 200, well, actually to 300 requests per second. And so there are a lot of users that are demanding job recommendations. And yeah, if we could realize such an online component, that I think would be very cool. Yeah.
Do you keep track of whether people who bookmark or view a job offer end up taking it, end up getting accepted to the job?
No, unfortunately not. We tried once to actually to find out, so whether, like, because in the CV you can then see whether a person switched to a given company, and you can, in the logs from the recommender, which go back almost 3 years, you can then see, did we recommend a posting from that company which has a similar title like the new title that this user now has, but the data that we gained from this was pretty sparse. So
don't the companies pay you to post the job offerings so that they get their attributes to you and keep using the services?
I mean, so what we keep track of is at least what we know whether people got interested and click on some apply button, but we lose then the connection, the clear connection, whether this candidate then actually got the job in the end, got that job in the end. Yeah?
My question is regarding to your evaluation system. I mean, this 30 top, if the result is in the 30 top, how have you decided to use such a system? Because 30 sounds for me too much for a user who's using Sing. There are top, and I have one more question. That is, have you considered hosting your challenge on the Kaggle? Well, I'm pretty sure that you did, but.
Yeah, we did. So to answer the last question, yes, we considered this. In the end, the decision. So since our plan was our wish was actually already this year to go towards online evaluation, we thought, okay, it's better if we have the submission system also on our premises, so that we can then, like, that it's easier than, given the solution files, then also roll them out in the recommender. That was one reason why we then hacked together an own system. Yeah. Regarding the evaluation measure, it's if you look at, for example, the precision at K reflect actually the use cases that we have on the platform. So on the start page, we show either top 2 recommendations or top 4 recommendations. On the jobs page, we either show top 6 recommendations, or if the user clicks on more, we show top 20. Regarding recall at 30, I actually don't know why we didn't use recall at 20. But I think we looked at for this data set at the number. So how many users do we actually have who have K relevant items in this week for which you should predict the interactions? And yeah, I think if I remember correctly, then 30 was somehow was a reasonable choice, because there are not so many people who have more than 30 relevant items for that week. Yeah?
You said that you took out the taxonomy from the challenge data. Does that affect somehow the result, the precision of the evaluation?
No, we didn't took it out. We are using it actually.
Just confused it, obfuscated it.
Sorry. Yeah, no, to be correct, yeah. We didn't use the hierarchy that we have in the among these job roles, for example. This we didn't use, but what we used is if there was a string appearing in a job posting, like data mining expert, then yeah, our entity detection resolves this to an entity that has ID 6940, and this 6940 is the concept which has labels like data mining expert, data scientist. So you benefit already from these IDs refer to concepts, and you implicitly have then, you don't need to find synonyms, let's say. If we would have given out the raw text, then it would have been part of the participants would have need to solve this issue also of understanding, are two terms similar to each other, or actually do they refer to the same concept? But for two reasons, I mean, for privacy reasons, we didn't give out this strings. That was number one point, and second point was also this: most of the text is in German, and we didn't expect that. Yeah, I mean, in German, so most teams that participate, we expected to not come from Germany, let's say.
So the concept hierarchy was part of the challenge data?
The hierarchy not. The hierarchy we didn't give out. The synonyms, let's say. But
so, and do you think that it affects somehow? Can you compare the recommendations with hierarchy and without hierarchy?
I mean, essentially, if I have no idea how big the impact of the hierarchy is, because in the job recommender itself, we are also not using this, but we use rather more association rules that we learn from the click behavior, let's say, so that we rather use something that if people who clicked on data analyst jobs also very often clicked on data scientist jobs, then we consider these two concepts also as similar. These two concepts are, like, according to our taxonomy, or they are different concepts, but still in the recommender we also make use of these association rules to yeah.
Okay, so if there's no more questions, then thanks again for
Yeah, thank you very much.